Constructive Voices, the podcast for the construction people, with news, views, and expert interviews.
Coming up on this episode of Constructive Voices, we're heading to the United States to find out about an exciting technology that's saving time and money in big construction projects. Its founder, René Morkos, tells us,
we are living in the most exciting time in construction, since maybe the building of the pyramids and the European cathedrals.
And of course, I'll be joined by Pete the Builder to talk about what's happening in the US construction market and construction technology.
Constructive Voices, brought to you by Lewis Access, British-made scaffold towers and access products.
Hello, I'm Steve Randall. In a moment, an update on a story we covered in the previous episode of Constructive Voices, but as I'm recording this on June the 25th, the news is still unfolding of the collapse of a condominium building near Miami. At least one person dead and many people being searched for by rescue teams. This is a story that the construction industry across the US and across the world will be watching very closely, and our thoughts are with those affected. Now, last time, Henry MacDonald talked to Professor Michael Parkinson from the University of Liverpool. He's an expert on urban regeneration and was telling us about a major riverside project in Liverpool centred around a £500 million stadium for Everton Football Club. There's been a development, and Henry's been talking to Sir Michael again.
UNESCO, earlier this week, published its recommendation that Liverpool be taken off the World Heritage Site list at a meeting in July in China. 21 UNESCO ambassadors will then decide whether to ratify the recommendation to delete Liverpool, in which case it loses status, or whether it can be given a deferral. Liverpool wants UNESCO to defer the decision to come and look again at the city, how much we've done. I think there's really a big risk that UNESCO will say, no, you're off the list. So this is the culmination of several years conversation, and we are now in the last chance saloon. It is really a very big moment for the city.
And how much is this to do with the new build that's happening down on the riverfront, principally the new Everton Stadium?
It's all to do with the North Liverpool docks, which had been derelict for 60 years and where nothing has gone on. You've got two issues. One is the plans of Peel Holdings to develop Liverpool Waters, offices and residential. That argument's been going on for several years. UNESCO don't like it. We do. The recent thing is Everton Football Stadium. They have planning permission and government have approved the planning decision to move from Goodison and put a brand new state-of-the-art football stadium on Bramley-Moore Dock, which is at the far end of the site, currently derelict and frankly next to a sewage treatment plant. And UNESCO has now said, we've worried about these tall buildings and densities for years. Everton, they say, is the final straw. And so there's now a risk we'll lose the status.
Critics of UNESCO will say, well, hold on a minute. Would you just prefer this part of the city to lie derelict and empty?
This is absolutely it. The problem for UNESCO is it can handle monuments and sites where they're not real living cities. Liverpool is a real living city. It had a terrible collapse 30 years ago. It's had a very good renaissance. It isn't completed yet. The North Docks are the worst part of the city. North Liverpool is the worst part of the city. I think Liverpool should say, we have done a huge amount right across the rest of the World Heritage Site to invest over £750 million. We take it seriously. We have done a great deal. Secondly, we don't want to lose the status. It's valuable and valued. Thirdly, we do have to, however, have development in the near North Docks. We think we can do this in a way that does not threaten the heritage status. So please, in July, don't confirm the decision. Come to Liverpool, see what we're doing, see what we've done, see what we plan to do, and let's have a grown-up conversation so that we can have our development and bring prosperity to people. We can invest in our heritage, modernize it, and bring growth. And you can feel confident that we have respected what you call the outstanding universal value.
Constructive Voices.
So, lots to talk about on this episode, and as usual, I'm joined by a builder with many years in the construction business. He runs his own construction company and is Ireland's favourite TV builder, Peter Finn. Pete, how are you doing?
Steve, my man, how are you? Great to talk to you again.
Yeah, very good, thanks. You're busy, aren't you, with TV stuff and obviously, you know, the day job too?
Yeah, absolutely. We're back recording the next series of Home Rescue. So our first show was recorded last week. So I am very tired after that, but it was really successful. And the construction industry is on fire at the moment. So lots happening, both personally and all around the world. Being honest with Steve, there's lots happening in construction all around the world, which is great to hear. And I suppose that's what we're going to drill down on a bit more today, isn't that right?
Yeah, absolutely. Because as you mentioned, you know, this is not something that's just happening in this part of the world. Everywhere, construction is huge, whether it's big government projects talking about infrastructure or whether it's just the huge demand for homes, which is crazy. I mean, we're going to talk a bit about the US market, but across the whole of North America, supply is lagging demand in housing, and that's pushing prices up crazily. But I mean, the US market is thriving, isn't it?
Yeah, it really is. The construction industry around the world is going very strong. And I think in the US, a bit like what we have here in Ireland as well, there's a huge housing shortage. And obviously, supply and demand, if there's, you know, people there looking for houses, there's a huge push towards that. They also have a huge need, and want as well, to improve their infrastructure in the US. The population in the world is increasing all the time, and those people need places to live across the world, but in particular in the US, where they're basically building pretty much new cities. Cities are growing. They're obviously, you know, one of the world leaders at high rise. So busy market over there, and the construction industry is a huge part of their overall economy. And we always know, like we hear constantly about, you know, the American economy is spoken about globally all the time, and things are changing in the US, but they usually change very quickly in that country, and they usually are very reactive and proactive to, you know, a changing of the guard. So I think that's another aspect to what's happening over there, is that now there's new implementations coming in from the Biden administration, you know?
Yeah, and there's so much going on at the same time. Obviously, there's the rebuild of the economy and the literal rebuild of infrastructure and homes, as we've said. But then there's the whole thing around the changing demands of the market. You know, there are people who want different types of homes, you know, and this has been driven by the pandemic. You know, there's the whole thing with office buildings and industrial, you know, all of those sort of demands have shifted and were shifting to some degree before the pandemic, but that's been accelerated since. And there's also a huge wealth shift, which is starting and is only going to intensify from the older boomers generation who generally hold a lot of wealth, and that's moving down to younger generations.
Yeah, I really have to agree. There's just so much transition in the world at the moment. We're moving so much towards tech, and I know that the construction technologies in the US are really at the top end of the market. They really are at the top of their game over there, and there's a lot of money invested in that aspect, which basically means people can be living, you know, at all sorts of different levels and earning quite well by working from home on technological stuff. The old school way of getting up in the morning and having your briefcase or your hard hat under your arm and heading off to work is kind of gone. It's different. Yes, there still is people on the ground. Yes, there still is people going to do their 9 to 5. Obviously, COVID had changed an awful lot of that. And I think there's still going to be a hangover from that. I think so many people are going to start working from home. I know Facebook have recently said that they're going to allow their employees work from home and obviously go to the office for a shorter period of time. So there's a lot of that type of stuff happening across the world. And therefore, people's minds are changing. Then people's ways of thinking about how they live are changing. So, you know, coming back to construction on it again, that means that people's homes are going to be different. It means that people are moving from the city and maybe moving a little bit further out to get that lifestyle of being able to live in the country with maybe, let's say, a bigger footprint of a house. And they're able to still work very close to the same capacity, if not the same or even better, because they're cutting out this commute time. So many things happening, and the construction industry is having to keep up with it and having to try and understand it, I suppose. Add in the fact that we're all just coming out of this pandemic, add into the fact that there's a shortage of materials, and all that type of stuff going on. So it's very, very interesting times in construction. And so it's great for people like me and you, because that's what we love to talk about, Steve.
Yeah, exactly. And I mean, the challenges for the construction industry, and let's sort of talk specifically about the US, labor shortages, just finding the people to do what was required a couple of years ago. But as we've talked about, that's intensifying. There's more construction demand. Getting the people to do it is an increasing challenge.
Yeah, without the shadow of a doubt. So, I'm actually usually fairly good with figures, but these figures are blowing my mind here. I hope I'm even going to say them properly. The construction industry in the US is expected to be 191,000 million. Now, I know you can break that down into billions and maybe into trillions again, but that's what it is. It's 191,000 million.
Wow.
Alone in the construction sector. Now, large part of that will be infrastructure as well. You've got hospitals, you've got all those type of things being thrown into the mix, and then you've got your residential as well. So it's a huge market. It's a phenomenally big market. And I suppose if you look at the amount of bodies there are in the world to try and throw into that, and educated and skilled people to get to do that volume of work, it doesn't really add up. So therefore, we've all seen the movie, Steve, but robotics is coming, and René from Alice Technologies he mentions this, and this man is in the know. This man is not down the pub having a chat with somebody else and passing on information. He's a Stanford professor, and he has said very clearly that robotics is going to play a major role in construction going forward. And when you listen to our conversation, it's quite obvious it has to happen, because we simply do not have the humans available to do it, skilled and trained, and, speed wise as well. We're going to just have to accept this. Whenever we talk about stuff like this, the first thing that comes into my head is Terminator, the T-1000, they're all coming, I'm willing to take them on, but they're a tough old battle, it's starting already. We are part cyborg, because we all walk around with that smartphone in our hands, and that has so much information, and we input information into it, and it communicates with us all the time. So I know people like Elon Musk always say that humans are already part cyborg, and when you think about it, we kind of are. So we rely on technology so much more, and when it comes to construction, again, it's always adapting, it's always moving, it's always getting faster. And we've done lots of different things throughout the years to increase our speed and to increase our productivity, to increase our profitability. And it's usually the more technology that you use in terms of how you design something, then how you plan it. And now the next thing is how you actually construct it is going to be more reliant on technology. And it already is there. There's BIM models being used by architects, engineers. Now that's filtering down further. I see BIM models all the time, even on my own construction projects. And I'm able to look at them, and they're 3D images, and you can walk through walls, real kind of Mission Impossible type stuff, and you can kind of see the full layout of a building, the full skeleton of a building. You can reverse it, looking from all these different angles. And it's really, really good to be able to see that and do that. And you can do all these clash detections. You can do all these type of things which help prevent errors happening, help reduce the amount of time lost on site, help increase productivity. But then again, when you think about the figures that we discussed there earlier on and the volume that is required, it's pretty unrealistic to expect humans to be able to do it all. So the robotics is definitely going to be a major part of our future. And I think we need to tie in with that sooner rather than later. And I think it's one of those things, if you get on early, maybe you're going to be in a better place.
A company called ABB, who are very much involved in robotics and all kinds of technology, they've done a survey of construction industry CEOs and MDs across the world, and more than 4 out of 5 of those respondents say they're planning to introduce robots into their operations. And then it's partly due to the growing skills crisis.
But I suppose that's just people in those positions, CEOs and people in those management positions in large companies in particular, like they can see this coming. And, you know, whenever I think of robots on site, or whenever I think of robots doing something that normally you would associate with a human, you always picture the robot with its kind of, you know, its round head and its, you know, clunky arms, and it's kind of walking along like that. But like, I actually only recently looked at a video of a robot. It was called a robot, but basically what it was a truck. It was laying blocks in Australia, and it had like a high-ab arm on the back of a truck is the best way to describe it. So the block truck then came up and fed blocks into this high-ab at the back, and this basically extended arm came out. It was connected to a computer, obviously in the cab, and it was just laying these blocks out like a conveyor belt was coming down through the arm of the high-ab in the exact position. So error was removed. The blocks were able to be laid up to a certain height without any humans being involved. So therefore it was safer. The site was immaculately clean. So there was a whole lot of advantages. And like, the word robot didn't really describe what I was looking at. I was looking at a truck that had a high-ab arm on it that was laying the blocks. I know that is a robot when you break it down, because it's being, you know, robotics is what's making it perform what it's done or doing. But it was really, really interesting. It changed my mind. I always had this, I don't know why, maybe it's just my caveman brain, but I had always this idea of, you know, robots walking along the scaffold and things like that. Of course that's not the situation. Of course that's not it. Like, the robots aren't going to be going down to local builders providers and buying a trowel. Like, the reality is it's just using completely different systems. And you know what? Unfortunately, I have to say it, they're safer, cleaner, more accurate, faster. So now, at the moment, like anything, it's like when you've got your first smartphone, it probably cost you a fortune, but you were ahead of the time, so you were willing to do it. Nowadays, you can buy a smartphone. Like who doesn't have a smartphone is the best way to describe it now. So these things will take time to implement. It is already kind of with us, and it's coming, and I think it's going to start working its way down the chain where we actually see so much more of it on site. And I think I suppose we're just going to have to accept that we just need to tie in and get with the program. You know, there's huge opportunities here for companies in the US to sell to Europe and to the rest of the world, and vice versa. In the construction sector, there's so many opportunities, and there's so much there's so many spaces there that people can step into and can fill these voids. So it's really exciting times, and there's a lot still to be played out in this story, you know.
Yeah, absolutely. And as you mentioned, we are going to be staying stateside with a Stanford professor talking more about artificial intelligence and other technology. Pete, we'll chat again, well, next time, assuming we haven't been replaced by robots of some sort.
Thank you, Steve. It was very good to talk to you.
I think that was Pete.
Cheers, Steve. Great to talk to you, mate.
Constructive Voices, the podcast for the construction people.
Now, technology increasingly plays a part in almost every aspect of our lives, both at home and at work. But what about specifically artificial intelligence, or AI? How can that help the construction industry to build bigger, better? We've been finding out more. Phil Carpenter has been speaking to René Morkos, who's the CEO and founder of Alice Technologies, and asked him first to explain what ALICE is.
ALICE is an acronym that stands for Artificial Intelligence Construction Engineering. And so it is the world's first generative construction simulator. It's a bit of a mouthful, but it's actually pretty simple. And so what that means is it's a tool that enables you to take large projects, put them into the software, and Alice will generate millions of different ways of building a given project. And she does this by, building it with one crane, two cranes, overtime, no overtime, 20 steel crews, 23 steel crews, 25 steel crews, and so on and so forth, going through lots and lots of permutations. And every time you change one of these input variables, Alice propagates that change through the entire system and re-simulates the entire construction project. So you can immediately see the impact that a delay will have, or a design change will have, or a different type of concrete, or a different production rate, or whatever it is that you're trying to figure out. That's what Alice is. First system in the world that can do that.
If you would, tell us a little bit about your background and why you started Alice Technologies.
I'm a second-generation civil engineer. So when I graduated high school, my dad gave me a good piece of advice. He said, son, study anything you want, just don't study civil engineering. So I was like, great, that's it. I didn't know what I want to do with my life before this, but now it's clear to me. And so I obviously went and studied civil engineering. I've built stuff. I've built stuff around the world, Phil. You name it, pretty much I've built it. I've done underwater pipelines. I've done $350 million gas refinery in Abu Dhabi. I was in Afghanistan for a year. I always like building. The concept of going somewhere and putting something into reality that didn't exist before, and that thing being very big and sort of outliving you, just always jazzed me. Like, that would get me out of bed in the morning. I really liked it. I like coming home with concrete in my hair. I really like building stuff. And so, long story short, I ended up doing a PhD at Stanford. There's kind of these two moments. One was in Afghanistan. I was building these landing strips for F-16s. And I was trying to figure out how to sequence, the people that I had on site. What was the optimal sequence, right? I'm trying to figure it out. A large slab, probably 23 different pieces in that slab, or 24. And 30 people, and how do you sequence it? And that seemed like a very simple problem. After, doing my PhD, I realized that was actually relatively complicated. And the other thing I started to look at was space usage. And this is kind of an interesting sort of observation. Look at any construction site. Drive down the road, look at a construction site. It's going to be empty. There might be a pocket or two of work, very intense work, but generally the construction sites are empty. And so I measured in my PhD, we took these photographs on site and measured that on average, 3% of construction site space is used for construction. 3%. So it's like, holy cow, like this is a really low number. Other industries have asset utilizations in the order of 50, 60, maybe even 70%. And so started researching, how do you increase space usage while avoiding spatial clashes? You don't want people working on top of each other. It's unsafe. And so I started developing these algorithms that would do that and generate options. And, that journey really led me to build Alice, right? Which was, there's a moment where I suddenly realized, like, wait, these algorithms aren't just optimizing space usage, but they're actually building. That was like this big moment for me in my life, right? It was like hold the horses, like what the heck? Like this algorithm knows how to build. I remember kind of, telling my, like jumping up and down, like this thing knows how to build, and it's which I, I was always like, hey, I've been doing this for, that point, a good 6, 7, maybe 8 years, right? But and suddenly it's been a really, beautiful journey, right? And I remember thinking at the time, Alice knows how to build. She doesn't know how to build very well. And so, she didn't know how to, model cranes, and she didn't understand calendars, and she didn't understand labor, and she didn't understand consumable, reusable, right? And so we slowly taught her all these little concepts, right, over the last, 6 years. And sometime around 2 years ago, we cracked it technically.
And when you were doing your PhD work, René, did you have advisors or colleagues or even fellow students who said, wow, you're onto something, like this could be a company?
Not in the beginning. And that's kind of, I think, the really beautiful thing about it, right? People always say, like, do what you love. Like, I can tell you, Phil, that the first 4 years, maybe 4.5, 5 years, like, there was no inkling that this would ever be useful. I was tinkering around in the lab, and I was happy. I was happy as a clam. I was working, sometimes 19, 20, 18 hours a day, 7 days a week. And I was just futzing around with these like little algorithms. I was like, oh, this is so much fun. Like, I can't believe that I get to just sit here and do this. As a PhD, obviously, you don't really earn anything, but you get to kind of just play around with these things. And that was it. There was a point at which suddenly, my advisor at Stanford was like, I developed these algorithms, and he said, go validate it with a project manager. And that's a very like Stanford thing. It's got to be sort of bounded in reality. And so, and I remember saying, but, John, this guy's in Amsterdam. And the response was, I don't care if he's on the moon, go validate it with the PM. So I thought to myself, what the heck? So I called the guys up in Amsterdam and I said, hey, do you want a free week of consulting? Because, I couldn't afford a plane ticket. And they said, yeah, sure. So I said, okay, I just have to talk to Willem, at 4 p.m. on a Friday. So I flew down there and I showed it to Willem. And that was the moment. Willem kind of double checked my work. And that's when it hit me. I was like, oh my God, this thing, it knows how to build. So when I got back on the plane, flying across the Atlantic, kind of sipping on a Heineken, I'm just like, this algorithm, it knows how to build. So I kind of got back to Stanford, started playing with it. And then I entered this BASIS competition. It stands for the Business Association of Stanford Entrepreneurial Students. We won this competition. We were voted like the best product coming out of Stanford. And that's kind of when it started to become like, hey, other people think this thing like is really cool. Yeah, and then suddenly, we raised some money, and one thing, led to another. And they say the best companies aren't, founded; they just happen. And that was, definitely the case with Alice.
That's a great story. Tell us, René, if you could. Clearly, people were excited about what Alice was doing and what it could become. What specific problems does Alice solve, and how does it do that?
Construction has seen a stagnant productivity increase over the last, 5 decades, 6 decades, depending on which report you're reading. And what that really means is that the dollar value per hour worked has stayed the same in construction, right? Most people sort of in construction have heard this or know this, right? We're the second least digitized field in the world after agriculture. And so the problem that Alice really solves, I'm going to give you a slightly different twist on what it is, right? It's the world's first theoretical platform, because there's a lot of theory that we've built around it, right? That enables the application of artificial intelligence, machine learning, advanced optimization, and other cutting edge, bleeding edge techniques and technologies that other fields have developed to construction. That is one way of viewing Alice. What we've built is a platform that enables unlocking all these other technologies to our field. And so the specific problems that it solves is it enables you to build a construction project 20 or 30 different times before you need to build it. Alternatively, it enables you to build a construction project 20 or 30 different times if there's a delay to find the best one. It's incredibly powerful because let's assume that you're in a project, right? We got called into a project recently, right, that had very serious delays, right? They're looking at potentially 12 plus months, right? Very substantial liquidated damages, right? And so they're sitting there, and anybody that has been on those jobs, I have. I was involved in a job where I was a site engineer where we're looking at 50,000 euros per day, right? And those jobs get really, really stressful. Every day you wake up, it's 50,000 out the door. Next day is 50,000. Next day is, and imagine that instead of you trying to sort of piece together on the fly, because there's a lot of stress, things are moving quickly. Your management systems, your Primavera, your Microsoft Project, your estimation systems, none of these can update in real time. And that's what this tool does. Instead of saying, okay, well, I'm going to add carpenters, but you realize, oh, well, I added carpenters, but there wasn't enough formwork to support the increased carpenters, or I added a crane, but I didn't have enough steel workers, or whatever it is, those interdependencies, right? As you realize down the line that there is an interdependency that you didn't see, that's what you can do with the tool. Right, you can actually rapidly explore, okay, I've tried 6 different ways of doing it, okay, let me call a site meeting and say, hey, listen, everybody, the best way out at this point in time is increasing, the number of whatever it is, road, crews by, 6, right, and having them work these 3 Saturdays. That's the fastest way to do it.
So Alice uses artificial intelligence to help work its magic. Why do you think that AI is particularly well suited to solve the problems that Alice addresses?
That's a great question. Here's something to think about. Let's assume you have 9 columns, right, on a little building, and you're trying to figure out how to sequence them. So there's 9 choices for sequencing the first column. There's 8 choices for the second, 7 choices for the third, 6 for the fourth, and so on and so forth, right? There's actually 362,000 ways to schedule 9 columns, to sequence 9 columns, right? One at a time.
Yeah.
So imagine if you're looking at a large billion-dollar job. Let's assume that you have, 3 zones, maybe 4 zones. You're trying to figure out number of crews. Let's assume that you're only looking at, structural crews. There's 5 types of crews, right? So how many carpenters, how many steel workers, how many masons, and how many MEP insert crews, right? If you just look at 1111, 1112, 1113, 4, 5, and so on and so forth. Let's assume you're only looking at 4 of each. That's 4 to the power of 4. The number of sequences is 4 factorial. The number of cranes. So each one of these options multiplies a number of possible solutions. And so for large projects, you have in the order generally of 1 trillion different ways that it could be built. It is not feasible or desirable for a human to have to generate all those options. It's not just that it, as a human, you don't have time or you can't crunch in your head, let's say 6 million or 60 million different solutions like Alice does, right? But also each one of those, here's a typical example. We were on a job recently that had 5,000 tasks, 14 different constraint types, calendars, cranes, labor, equipment, materials, and so on and so forth, across 700 days. So 14 times 5,000 times 700. That's the size of the problem that you're asking the human to crunch in their head. So what I'm trying to explain is that the number of constraints that you need to resolve is very large, even for one solution. So what humans do is they take shortcuts. Humans are good at gut sense. But as you know, those shortcuts lead to inefficiencies. And so, one, the size of a given solution is very large. And so you need AI to crunch it. B, there's lots and lots of solutions. So there's maybe 6 million of them. And so those are the two reasons that you need AI to kind of crunch this.
Wow. So really, before the application of this technology, there's no way that people could have dealt with sort of gaming out this many possible solutions to problems.
Yeah, there's no way. Really, one of the nice things about Alice is we get to be involved in some of the world's top projects, largest, most lucrative, NDAs up the wazoo, like just lots and lots of projects. It would be difficult for a site engineer or a project manager to be involved in this many different types of projects, right? And so for us, we really have a good idea of what current practice really is. And I can tell you that I have rarely seen 3 different scheduling options or 3 estimation options for a project. Folks might have 2. I've seen that a few times, but I'm not seeing 3.
Now, you have described Alice as doing something called generative construction. What does that mean, and why is it important?
Well, it's not just important, Phil. It's really, really exciting. So here's what it is. If you are not familiar with parametric technology, parametric is the precursor to generative. You will be an expert in about 30 seconds. So what does parametric technology mean, and why is it a big deal? So let's assume that you wanted to draw, an object, say a cylinder. You draw sort of a circle in the plane. And then somebody comes along and says, hey, I want a bigger cylinder. So you redraw. A little while later, somebody says, hey, I want a smaller cylinder. You redraw. You got to redraw the cylinder every time. With parametric technology, you change the parameters, the height and radius, and the tool redraws your object. Kind of useful. Now, imagine that you're, say, designing a car engine or a building, right? And somebody, my boss in Afghanistan walks in the office and says, hey, I want to move the staircase. So I'm thinking, like, drat, I've got to change all the cross sections, all the elevations, the 3D model. Like, that change ripples through 47 drawings that I had at the time. If your tool's parametric, you simply go to 3D model, move the staircase, and everything updates for you. The way I tend to explain it to myself is the ripple through effect. A change in an input variable ripples through your system. Generative means that you're now, as a human, we're good at being lazy. So you're like, well, I don't want to change those parameters manually, right? I want you, the computer, to change parameters from 0 to 100 by, half digit increments. And I want you to try all the pipe diameters from like half an inch to 1 inch, or the height, column heights from 10 feet to 16 feet, or whatever it is. And I want you to give me the answer that has the highest rentable area, or the lowest energy requirements, or the highest power output, or whatever it is. So does that make sense?
It does, yeah.
Exactly. So this was a big deal in design. BIM, which was like a big, step forward for our field, and that's AEC or ACO. But BIM is fundamentally 2 technologies. It's object-oriented, which means that the software understands that it's a column made of concrete on the 3rd floor, and it is parametric, so that when you move the window, the hole in the wall moves with it. So that's what BIM was, and it was, I think, a big step forward. This has been played out in design over the last 35 years. The first parametric tools actually were coming out in the 80s, believe it or not. The reason that it was done in mechanical engineering before construction was because buildings are bigger and more complex to model than engines. And so the technology existed. It was the processing speeds that needed to catch up. And that started to happen in, I'd say, 2010-ish. And so that's been played out. This parametric design has been played out over the last 35 years. In the last 3 to 5 years, we've seen, the introduction of generative design, tools like Grasshopper and other tools where you can sort of explore, tens of thousands of design options. What's never been done is it's never been done in construction. It's in fact been deemed impossible up to now. And that's what Alice is. It's a generative construction tool. You can change parameters, such as the number of cranes, the number of crews, the design. And that's a really cool one. You can upload a new design, copy the rules from the old design, and hit resimulate and see the impact of this new design immediately. And so that's what generative means, and why I think it's really exciting. It's a big deal, right? I think it puts us on par with other sort of, cutting edge fields. So that's why I'm so excited about it.
And I know that generative design has been used, for example, in the automotive industry. Where else have you seen it used?
Automotive industry, shipping, airplanes, anything mechanical engineering, right? There's a company called PTC, Parametric Technology Corporation, that really, invented this stuff, right? And I think they were founded in 1984.
Now, Alice started with a really tight focus, René. It was the scheduling phase of construction. But more recently, you expanded the business to address the building phase as well. Why did you make that decision to broaden your scope like that?
The really exciting thing about inventing something, hacking something out of thin ice that didn't exist before, is that you yourself are a student of the thing that you're building. And so what we started to realize with time was we thought we were building a scheduler. And at one point, it sort of hit me. It was like, wait a minute, it's not a scheduler, it's a simulator. Small nuance is really, really important. A schedule is, a bunch of bars, tasks, and time. That's what a schedule is. A simulation is different because it's actually moving, shuffling resources around and actually building your object. Building your product, building a building, building an airport, whatever it is, right? And so the schedule is just a viewpoint, one view of your simulation. The estimate is a view of your simulation. The 4D video that's automatically generated by Alice is a view of your simulation, right? All of these things are side effects of the simulation, if that makes sense. The analytics, the idle times, the crew utilization graphs, the daily reports, the 3-week look at, all of these things are just merely side effects or different views of that simulation. And so as we were building it, what we realized was, it's not just a schedule, it's a simulation. B, that as we were building it, people were liking it. They said, hey, this is really great. You guys are really, killing it in the pre-construction phase, but, how do I use it in construction? Because, I love the software. I love the invention. It's really great. I'm excited about it. I've had people come to me and say, I never thought I'd say this, but I like scheduling, and that really kind of makes me very, very proud. But what people would say is, hey, I like it in the pre-construction phase, but ultimately I've got to go build it. That's where the value is, right? I get that you saved me, time and money by telling me I needed 2 cranes instead of 3, or 4 instead of 3, or whatever the insight was, right? But I now need, the rubber needs to hit the road, and you've got to go build it. And so we went down and built it. And it wasn't an easy thing to do, and I don't know if I'm getting a little too technical here, but, what you're really doing there is you're saying, hey, this is my original simulation. This is my original schedule that I'm going to go into this with. And halfway through it, I'm going to cut it into 2 halves. The stuff that's completed, the stuff that's not started yet, and the stuff that's in progress. And now what I'm going to do is I'm going to re-simulate the remaining piece. And the reason that can be tricky is that when I created that remaining piece, I assumed I had 2 cranes, but one of them broke down and now I have 1. And so I've got to repropagate that constraint through the remaining part. This is the thing that's such a challenge in construction sites. Anybody that's been on a construction site, especially if the job is under some kind of time constraints or some kind of time pressure or budgetary pressures, right? These are the things that take you 2 or 3 weeks, whereas with Alice, because you set up a simulation, right, you literally can just update, hit the button, and there's only 1 crane. What's the impact if I do nothing? What's the impact if I resequence? What's the impact if I try overtime for steel? What's the impact, so on and so forth. And those are all take you a couple of minutes.
Got it. Okay. I'm curious, René, are you seeing AI being applied to other aspects of construction? And if so, I'm really curious where and why.
We are living in the most exciting time in construction, since maybe the building of the pyramids and the European cathedrals. Over the last 2 millennia, this is the, renaissance of construction. It happened in 2017. What's happened is that I am today convinced, teaching at Stanford, sitting in Silicon Valley, being friends with a bunch of other entrepreneurs that are in construction tech. What we are witnessing is there will be a new ecosystem that is coming at us in our field. A new ecosystem where the fundamental value proposition of the general contractor is going to slowly change. And that new ecosystem is going to be based on data. You'll be able to generate lots and lots of options. You'll be able to know who's building what, when, and where. You'll be able to do things like, JIT, just-in-time delivery. You install a wall panel and it immediately orders the sockets, whatever it is that you need, it automatically. You'll be able to, access a network of suppliers through an automated sort of digitized system. So incredibly, incredibly exciting period. And it really, I think one of the things that's interesting to note is that the reason it's happening now is not, and this is something that I'm really very, a firm and ardent believer of, it is not that construction folks are not innovative or lazy or whatever, the sort of stereotype is. It's simply put because we deal with problems that are bigger and more complex in other fields. Finance was one of the first to get digitized. You tell me how hard is it to digitize a number of accounts, or if I withdraw $10 here, it's got to add it over there, right? That's relatively easy. Try digitize something like construction. Well, we couldn't do that until we digitized design, and the computers weren't fast enough to do that till 2010. So there's a reason it's happening now, and it's definitely not because folks aren't innovative. It's just that if you have built a $350 million gas refinery, you're burning through $2 million a day at the peak of it. You're going through 2 million documents. I don't think people realize the size and the complexity of what we're dealing with, right? What you asked is, AI and ML. What we're seeing in 2017 was when sort of, I think the world collectively sort of realized, or at least the venture capitalists suddenly realized, like, wait a minute, there's a tipping point. The machines are fast enough to crunch problems this big. The design has been digitized. There's something big that's going to happen here. And then all this money kind of got flooded into construction tech. And if you remember back in 2017, there's a number of these startups that kind of mushroomed up. And so, it's happening. It's not even you going to see, you're seeing it already, right? It's the digitization of various aspects of the value chain, right? The digitization of the supply chain, the digitization of engineering, of procurement, of, if you look at Autodesk's, purchase of Building Connected, what Building Connected did was digitize, the bidding aspect of construction. There's lots of other sort of fields that are doing it. And the last sort of piece of the puzzle is robotics, right? So you're seeing companies like Canvas or Tybot or Dusty Robotics, right? Like, small applications, right? But we're starting there. And what you're going to start seeing is that the fundamental sort of building pieces, and forgive the pun, which is, design, engineering, procurement, pre-construction, construction, like all of these things are getting digitized. And what you're seeing also is robotics are getting developed. And so the interplay between that digital world and the robots is what is going to start happening. And it's just incredibly, incredibly exciting.
Tell us, if you could, René, what kinds of companies are you working with today, and how are they making use of Alice?
We work with some of the biggest names in the industry. Bouygues, Parsons, Takanaka, Austin Bridge and Road, a number of these, high-end construction companies. And like I pointed out, we work on some of the largest projects. I think the smallest job we ever did was a $12 million parking lot. That was really early on. And the biggest job we ever did was a $3.7 billion hospital and everything in between. Yeah. And what we tend to focus on these days is jobs that are about 100 million and up. Right? We've done as low as 50. Jobs that are 100 million and up. And the impact that you tend to see with Alice is, on average, we save our clients about 17% in construction duration, and we save about 13% in labor and equipment costs. Those are sort of the figures that, after sort of working on this for 6 years and the company form at this point, the numbers have kind of converged.
So you're doing something new, and sometimes that comes with adoption challenges. When you see those, René, amongst your customers, what do they look like, and how do you overcome them?
That's a great question, Phil. Again, like I said, I really don't think that construction is not innovative or they don't adopt technology. Construction folk have been burned in the past, because I really do believe that for a long time there haven't been great tools. I mean, ask any site engineer that's been on a job, right? And they're leaving the site office at 7, 8 p.m. for the nth time, how great their tools are. Ask anybody, who's been on a job, like, hey, when there's a delay, how useful was your computer in telling you what was the best way out? That would elicit a laugh, right? Because I can tell you that today's tools are really fundamentally useless, right? And so when it comes to adoption, the nice thing about innovation is that it is really, in many ways, a great equalizer, right? And what I mean by that is that I, really believe in an egalitarian or an equal world. And so what you'll see is that, like in every other field and in almost every human endeavor, there are folks that are not innovative and they don't want to go through, because innovation, a lot of people use it, but it's difficult. Right? You're doing things that no one's done. You're trying, you're failing, you're iterating. And so even with something like Alice, like, it's a software, but the software is only as good as the people using it. It's only as good as the processes that it enables. And so what you'll tend to notice with our clients is that, they'll use the tool and then they go back to the drawing board and they go, wait, like, this is really powerful. Suddenly I can generate 50 options where before I could barely do one. What does that mean? How do I want to think about this? How do I want to, approach it from a risk analysis, perspective? To answer your question, adoption challenges, every field has innovators. Every field has people that are willing to push the boundary. And we're so lucky at Alice that we've really interacted with some incredible people, right? Really incredible people that are working on some, advanced technologies. And you'd be surprised. The top companies in the world, the names that I've named, like, Parsons, Austin Virgin Road, Takanaka, Bouygues, they have, advanced research facilities. I have been surprised. Some of these companies have developed, in-house software platforms that, enable parametric, structural design, right, that I've never seen before, right? Like, robotics, research, right, and so on and so forth. So, yeah, you'd be surprised. There's folks out there that are innovating and they're, they've got their nose to the grinding stone.
So you and I are here in the United States, and here the Biden administration appears poised to spend more than $2 trillion on infrastructure. How do you think Alice could help infrastructure-focused GCs to spend American taxpayers' money more effectively?
We've seen some of the biggest advantages. I mean, that's infrastructure jobs is where Alice has knocked it out the park. We sort of pivoted to focus on infrastructure about 13, 15 months ago, something like that. And that's where Alice has really, really excelled. The size of the projects, the data you need to run the software, there's a number of factors that contributed to that. But Alice has been really effective at running infrastructure jobs. And we've deployed it on, the Parsons $2.6 billion Edmonton rail. We've deployed it on several, highway jobs in Canada, in Texas, in Virginia, and a number of other places. And like I said, generally what you'll tend to see is savings in the order of that 17% of the duration, right? And labor and equipment, substantial improvements in the cycle times, right? Because what you're doing with Alice is you're figuring out what is the right ratio of resources. That's the big question. People think it's what's the right number. It's actually what's the right ratio.
Now, you have said, René, that your vision for Alice is to help reduce the cost of construction by 25% globally. So that's an audacious goal. How big a dent do you think Alice can put in worldwide construction costs?
Yeah, I really anticipate that will happen in the next, 10 to 15 years. With today's technology, right, with what we've built today, Alice reduces the construction durations by 17%, labor and equipment by 13%. It does this by squeezing out inefficiency. And that's why I didn't mention materials. There's not much we can do. You need that many materials to build your job. What we can do is reduce, for example, formwork. But if you look at labor and equipment costs, they tend to be 40% of the total. So today, Alice is saving about 6% on costs. And the fact that you're finishing that job, 15% faster, right, which is say a month, or 2 months on a 1 year job, that's also, improving your profit margin, right, which reduces cost. So today, if you're looking at the system, you're getting somewhere around, in my opinion, 7, 8, maybe even 10% right, that you could sort of knock off with the current technology. As you will see the digitization of the construction ecosystem, the integration across these systems, right, will result easily in an additional 25%, if not more. And that will happen really in the next 10 to 15 years.
Wow. One last question for you, René, and it's this. So the construction industry here in the United States is suffering from a labor shortage, and many older workers are retiring. Do you think that the accelerating adoption of new technologies in the field will help companies to attract and retain younger workers?
Absolutely. No, there's no question. I think that it will help attract, retain new workers. Something like Alice can also tell you how to build a job with less people. I'd say in 60% of our deployments, that question comes up, right? Well, we don't have additional crews. What do? We're building a data center. How do we reduce the number of crews, right? So the software will tell you how to reduce the amount of labor that you need. And also the fact that it's a cutting-edge tool, or there are cutting-edge tools, will help attract the new generation of civil engineers to our field. That will happen, or I'm seeing it happening. I think the last thing that's sort of interesting is that with a software like Alice, you're also saving them knowledge of how to build a given project. That's a big deal, because when you look at construction companies today, their systems, I'm saying the people, but their systems are just about as smart today as they were a year ago. Right? You build 3 hospitals. The people that have built those hospitals are 3 hospitals smarter, but your ERP system doesn't tend to be 3 hospitals smarter. And with something like Alice, you can help retain that knowledge through the use of the Alice recipes and other things, because you fundamentally taught the computer how to build a hospital. I mean, that's what you've done. You've simulated it. You've built it 20, 30 different times. Your computer's built the hospital 30 different times, right? Or the highway or the bridge or whatever it is. And so you can then go back and say, hey, you've done this 3 times. Help me analyze what we've learned here. And the data is stored or compartmentalized in a way that makes it accessible and reusable. And so your systems become smarter with time.
That's so interesting. Well, if the people and the technology, if they're both getting smarter together, then I think that's pretty powerful. This has been great, René. Thank you so much for the time. I think you've got a great entrepreneurial adventure ahead of you.
Thanks so much, Phil. Really appreciate it.
There's René Morkos, the founder and CEO of Alice Technologies, talking to Phil Carpenter about his AI-powered construction simulation platform. I'm Steve Randall. Thank you for joining us on this episode of Constructive Voices. Don't forget you can rate and review us on your favourite podcast app, and follow or subscribe to get the latest episodes automatically. You can also find out more on our website, constructive-voices.com. Don't forget the dash. Join us again next time, and until then, thanks for listening. You're really helping us build something.
Thank you, Steve. It was very good to talk to you.
Constructive Voices, brought to you by Lewis Access, British-made scaffold towers and access products.